Welcome to GlassCode, and today we are going to look at selection sort. Selection sort is an easy to use, easy to learn sorting algorithm. Its time complexity is big O of n squared. And this means that as the list you operate on gets larger and larger, it takes exponentially more time. It is really good for small arrays where using more complicated and faster algorithms would be overkill and not worth the extra effort, but it's not very efficient on larger arrays and lists where you do need the more complicated sorting algorithms. Selection sort is an in-place algorithm, which means that it only operates on the list or the array that's given. So for that, the space complexity is big O of 1, or constant space. Okay, so the procedure for selection sort is first, we're going to start with the first number. Second, you're going to mark this number as the pivot. Third, you will iterate through the list to find the minimum number. Fourth, you are going to swap the minimum number with the pivot number. Note that the pivot position is still going to stay in the same spot. 5, you're going to move the pivot one to the right or to the next position down the list. And lastly, you're going to repeat these steps until the list has been sorted. Now we're going to go ahead and look at an example. This is going to be our unsorted list that we want to make sorted using the selection sort. So going through the procedure, we're going to start at the first number and make this our pivot point. Then we're going to iterate through the list until we find the minimum. With 14, looking our way through, we found 10. That's the current minimum. Looking our way through, and it's just 10. Now we're going to swap the 10 and the 14. So that gives us 10, 33, 27, 14, 35, 19, 42, and 44. Once swapped, we then move the pivot one to the right. So the pivot is now under the 33. Then we repeat, and we keep repeating these steps until we have sorted the entire list. So let's do that now. So starting with 33, looking across, the minimum number is going to be 14. So we go ahead and swap. Then we go ahead and move the pivot point and repeat. 27, looking across, 19 is the minimum number. So we're going to go ahead and swap. And then we're going to move the pivot over. The minimum number is 27. So we'll swap. Then move the pivot over again. Looking across, the minimum number is 33. So we'll swap again. And then we go ahead and move the pivot again. Now at this point, the list has been sorted. However, the algorithm doesn't know that, and it would have to continue the final steps to get the pivot point to 42, and then get the pivot point to the last position at 44, and then the algorithm would stop. Essentially, what this algorithm does on each repetition of this procedure is it looks for the minimum number and puts it into the front position. Looks for the next minimum number, puts it into the front position. And it repeats this until the whole list has been sorted. Thanks for watching, and remember to subscribe and hit the bell for more videos. Leave a like if you have learned something new, and comment down below what you would like to learn next.